Alright, so a bit of help here with background knowledge exercise L. These are questions 20 through to 24, so the last 5 in there. Let's have a look at how we go. Jason wants to get to his girlfriend's house. Her house is somewhere on the highway. That would help if I get the pen. Somewhere on this highway. So there's her lovely house. Or perhaps over here's her lovely house. Not really sure. The distance in a straight line is 11.73 kilometres. He lives at the coordinates 4, 1 down here. And we want to know what are the coordinates of his girlfriend's house. Well, given that it's in 2 places, there are probably 2 possible answers. How would we go about working out this distance? Well, if we find the difference from his house to the road at right angles, so the shortest distance possible, I think you'll agree, if his y-coordinate's 1 and the y-coordinate of that line is 8, then the distance there is 7 kilometres. I'm going to use little d to represent the distance between that point of the road that's closest to Jason's house and then the distance along the road to get to his girlfriend's house, and you'll see that it'll be the same distance either way. So it doesn't really matter which one we find. Right angle triangle, you know what's coming. A bit of Pythagoras. So let's write out my rule. The hypotenuse squared, square on the hypotenuse, equals the sum of the squares on the other 2 sides. So 11.73 squared equals 7 squared plus d squared in this case. A little bit of rearranging. 11.73 squared minus 7 squared equals d squared. This time I'm allowed to just square root to get the answer because I know my answer must be positive. I'm not going to mess up and get a plus or minus issue happening here. So I straight away go through and find the answer by square rooting that left hand side once I've calculated it, and you get 9.41 is approximately equal to d. Note that I'm using approximately equals now because I've rounded that number off. So to find the coordinates of his girlfriend's house, I think we'll all agree the y-coordinate is definitely 8. And to find the x-coordinate, what I'm going to need to do is take the x-coordinate of Jason's house, the 4, and then either subtract 9.41, which gives me negative 5.41, or add the 9.41 on to get the house on the right, which is 13.41. So they are the 2 possible answers for the coordinates of Jason's girlfriend's house. Let's move on to the next one. Alright, so this should be question 21. Part A, a circle has a centre AB and a radius R. So you can see I've drawn a circle there with centre AB. There's my radius R. And PX is some point PXY, the point P has coordinates XY, is somewhere on the circle. It could be anywhere, it's really arbitrary. How can I show that x minus a all squared plus y minus b all squared equals r squared? Well, looks like a Pythagorean formula again, Pythagoras Theorem. Let's have a look and see what this side length here is. Well, that's the rise, so that's the change in the y-coordinates. If I wanted to find that distance there would be this y-coordinate of P minus the y-coordinate of the centre, which is B. In a similar way, that horizontal distance there is going to be this x-coordinate of P minus the x-coordinate of the centre there. Using Pythagoras' theorem, if I've got the square and the hypotenuse equals the sum of the squares on the other 2 sides, we're going to find the hypotenuse is r, so I've got r squared. One of the sides is x minus a, and I've got to remember to square it, and the other side y minus b squared. And we'll see that we have the formula that they wanted. So that's the first bit, and so that's what we call the general equation of a circle. It's general because it involves A's, B's and R's. It doesn't have specific numbers in there. And the form that this one is in is the centre radius form. So the radius being R and the centre being AB. That makes these questions in part B particularly easy to do. If I've got a centre 4, 3 and a radius 5, the equation of my circle is going to be x minus 4 squared plus y minus 3 all squared equals 5 squared. You can make that 25 if you like, that's quite alright. Either way it works. Next one, centre negative 1, 5, radius 2. X minus negative 1 will be x plus 1 squared plus y minus 5 all squared equals 2 squared. So you can see I just plug the coordinates of the centre where A and B go, and the radius, let's just square it and stick it at the end. The third one here, centre 0, 0 and radius 10, well x minus 0 is just going to be x. So I'll have x squared, and similarly if the y is centred at the origin as well, the y coordinate, so it's x squared plus y squared equals 10 squared. Straightforward again. Finally part 4, before we go on to use our centre and radius form, I'm going to need to find where the centre is, so I'm going to use my midpoint formula. So the centre is going to have coordinates that are the average of the two x coordinates and the average of the two y coordinates. So I think we're going to find the centre is going to be at 1, 3. Now you're going to need to find the length of the radius here as well. So let's see if I can make it. Well, that didn't work. I was going to try and make a little bit more room, but just use my thumb to draw instead. Not to worry. I'll see if I can do it this way. Well, I hope you didn't get seasick there. But we've got a bit more room, so let's see if we can keep going now. So I've got the centre. I need to know the radius. Well, if I put a centre at 1, 3, let's say that's 0.13, and then one of the points on the end of the diameter is at 3, 1. Well, actually, if I just find the distance straight across from the endpoints of the diameter, that would work. So we can find the distance using the centre 1, 3 or the entire diameter. I'm going to go for the centre. I started with that. Let's just keep going. So there's the centre 1, 3. If I went across 2 and down 2, that would be the point 3, 1. So what I've got here is a right angled triangle with a difference of 2 in the x coordinates and 2 in the y coordinates. If you use your calculator or your Pythagorean theorem, you'll find out that that side must be 2 root 2. Similarity there with one of your best friend's little buddies, which we'll get to when we do the unit circle and the special triangles. So I now know the radius length is 2 root 2. So the equation for part 4 will be x minus 1 all squared plus y minus 3 all squared, and I'm not going to write 2 root 2 squared, I'm actually going to square it to get something much nicer, which is 8. That's the second question. Let's move on. Question 23, find the centre and radius of the circles in each of these cases. Well, that's going to be pretty easy now. We've had a bit of a go at these. So let's just make a list for the 3 possibilities here, put them in a table and we'll be done. So the centre in the first one is going to be 1, 3. Remember it's x minus a, y minus b, or often you'll see them written as hk instead of a and b, still works the same way. So the centre 1 and 3, and the radius the square root of that number on its own. Square root of 4 is 2. The next one, nothing's being subtracted for x, so the x coordinate of the centre must be 0. That's a plus 2, so we must have subtracted negative 2, and the square root of 16 is 4. Finally, just x squared plus y squared, so 0 is the centre, and that looks like a 7, even though I managed to draw over the top of it there. So the radius will be the square root of 7. After question 21, that made 22 pretty easy. Let's move on. Consider the circle with the following equation. State the circle's centre and radius. We're getting good at this now, so let's just do that really quickly. The centre is going to be at 2, -3, and the radius, whilst we could write whilst we could write root 20, that would be a little bit ugly. What would we write? We'd simplify that. Remember, root 20 is the square root of 4 times the square root of 5, or just 2 root 5. That looks a lot nicer. Part B, show that 4, 1 lies on the circle. The easiest way to show that a point satisfies an equation is to sub it in. So let's sub in the point. 4 goes where x was, so I've got 4 minus 2 all squared, and then the y coordinate is 1, so I've got 1 plus 3 all squared, and we should find that this equals 20 if we're in luck. So when I sub in 4, 4 minus 2 is 2, 2 squared is 4, and the other side, 4 squared is 16, which is 20, which equals the right hand side, so we know we've got it right. Find the equation of the tangent to the circle at the point 4, 1. So the equation of a tangent is going to be at right angles to the radius, so let's find the gradient of the radius first of all. So that's the point from the centre, which was 2, -3, and to the point that we're interested in, which in this case is 4, 1. So the gradient difference in y coordinates, 1 minus -3, divided by a difference in x coordinates, 4 take away 2. So the gradient of the radius that we're interested in this one is going to be 1 plus 3 is 4, divided by 2 is 2. Therefore the gradient of the tangent, lines that are at right angles to each other, my hand leaving dots all over the place there, sorry about that. Lines which are at right angles to each other have gradients that multiply to equal -1, or the easy way to remember it is the gradient of one is the negative reciprocal of the gradient of the other one. So the gradient of this tangent, the negative reciprocal of 2, is -1/2. Almost there. I now know the gradient of a line and one of the points on the line, 4 and 1, so I can use my gradient point form to find the equation of the line. Give ourselves a bit more room again. So here, sub in the points, so the y coordinate is 1. Oh, I'm substituting in now, silly. So let's go back and put in that value for the gradient, which is -1/2. X subtract 4. Y minus 1 equals -x over 2. -1/2 by -4 is +2. Add 1 to each side and I get y equals -x over 2 plus 3. And we've found what we were after. The answer in the book looks a little bit different, so let's just put it in its equivalent form. If I multiply everything by 2, I get 2y equals -x plus 6. And if you want it to look exactly the same as the book, add x to each side. X plus 2y equals 6. But in our exams, if you just left it in that form, that's a very meaningful form. We can easily see the gradient and the y-intercept, so that's a great way to do it. Alright, one question to go, we move on. Finally, we're talking about perpendicular bisectors of chords of circles. A chord's a line from one point on a circle circumference to another point. A special chord you would always be already familiar with is the diameter. Find the centre of the circle passing through these 3 points, and I've drawn a little picture there in Desmos to help us out, by finding the perpendicular bisectors and solving them simultaneously. That seems a little bit annoying. Let's go through and find out what the points are, which are perpendicular bisectors, so they're going to cut those lines in half. Well, the first point here, if I average the x coordinates, I'm not going to show all the working because I'm going to run out of time on the recording and space on the screen. The average of the x coordinates from -1 through to 5 should be reasonably easy to find. That's 6 across, so that's going to be 3 units either side, which of course makes it the x-coordinate 2. If I add 3, I get to -1, I get to 2, add another 3, I get to 5. The y-coordinate's gone from 5 to 7, halfway between 5 and 7 is 6. So I've got the coordinates of that point. The coordinates of the midpoint of the other line, it's gone from 5 to 7, so in this case the x-coordinate will be 6, and from 7 down to 1, so the middle of 7 and 1 is 4. So we've done the first step, we've found the points that are at the midpoint of those lines. Now we want the perpendicular bisectors, so to find the equations of each of those, remember the perpendicular bisectors are the lines that are going to go through like this, and through that point like that, and they're going to cross over at the centre. So we're going to get there eventually. Let's now find the gradient of each of those lines so we can find the gradients of the perpendicular bisectors. So again, I'll just call this one number 1. This is chord number 2. So the gradient of chord 1, rise over run, well, we know how far up it went. It went up from 5 to 7, so that was up 2. It ran along 6. So the gradient of that chord is 1/3. The gradient of chord 2, it's running downhill. It went from 7 down to 1, so it dropped 6 and then moved across 2 units. So -6 over 2 is -3. Interestingly, that means that the perpendicular bisector is actually going to be at right angles, and if we were really smart here, we wouldn't need to solve these simultaneously. You can see that those two lines there are at right angles to each other. The gradients are the negative reciprocal of each other. So if I just found the midpoint of the line going through there, the centre would be the midpoint of that diameter. Let's go ahead and do that just so we know what answer we're looking for anyway. If I wanted to find the midpoint from -1 to 7, that's 8 between them, so I've got to add 4. The midpoint there would be 4 for the x-coordinate. For the y-coordinate, I've gone from 5 down to 1. Halfway between 5 and 1 is 3. I think I just told you a lie a second ago when I said the midpoint, yes, from -1 to 7 is 4. Halfway of that distance horizontally is 8. Half of that distance is 4. So if I go -1 plus 4, I should really have written a 3 in there, not a 4. Sorry about that. So we know the centre is going to be 3, 3. It's not the method they told us though, so let's go back and see if we can confirm that using their method. I've used red for the gradients of the chords, so the gradient of the tangent 1, of the, perpendicular bisector 1, let's call that PB1, and this is PB2. The gradient of the first perpendicular bisector must be -3. Gradient of the second perpendicular bisector is the negative reciprocal of -3, which is 1/3. We know a point on each line, we know the gradient, so we can have the equation of PB1, perpendicular bisector 1, is going to be given by y take 6, remember y minus y1 equals the gradient, -3, x take x1, which is 2. Let's make that look a little bit nicer. Y minus 6 equals -3x plus 6. When I add 6 to each side, I get y equals -3x plus 12. Perpendicular bisector number 2. Again, I'm going to use my gradient point form. You can see I was trying to adjust the size of the screen and forgot to change the symbol first, so I've got something else to rub out now. That's okay, let's get that done. Doesn't want to behave. Alright, we'll just keep going then. Perpendicular bisector number 2. Y take away 4, the y coordinate of the point that we know is on the line, equals 1/3. X take away 6, the x coordinate of the point that we know is on the line. Let's make it look pretty again. Y minus 4 equals x over 3. 1/3 of 6 is -2. I'm going to add 4 to each side, so y equals x over 3 plus 2. These expressions must be equivalent where they meet, so I can make -3x plus 12 equal x over 3 plus 2, and that's going to tell me where they meet. Let's get rid of the 2, so we've got negative 3x plus 10 equals x over 3. I could subtract now, but I know we're not great with our fractions, so let's get rid of the fractions and multiply through by 3. So I've got negative 9x plus 30 equals x. Now it's looking easy. 30 equals 10x, 3 equals x. Substituting that into either equation, let's use the one that's already set up over there. Y is going to be 3 over 3 plus 2. Y equals 3. So we found the coordinates, and lo and behold, they match what we expected when we noticed that those two chords were at right angles, and we could just find the midpoint to get the answer. There you go. That was a bit of a marathon, but I hope that's relatively clear. No pauses or anything, so if I got a little bit muddled along the way, I'm sorry about that, but hopefully that helps. Cheers.